Right, guys, the most important thing now is not so much all these laws of logs and all of the stuff that we did previously, but the most important thing is, if we revise, the log of x to base a. Okay, what do we know? The a must be a fraction between 0 and 1. It must be bigger than 1. It can be bigger than 1. And x must be positive. Okay, so that's the important conditions there. The other important thing is if x is equal to 2 to the y, we can introduce the log notation. Okay, the other thing, if you've got log of x to base 2 is equal to y, that 2 shoots up and we drop the log and we get that. So you can also reverse this process as well. Okay, very, very important, these rules for log equations. Now it's starting to get very important, so you must really listen now. So hold on to those rules, we'll refer back in a moment. Let's have a look at an example. If I said to you, solve for x, now here it comes, solve for x. The log of x to base 5 is equal to 2. The log to base x of 5 is equal to 2. Okay, we've got to solve for x here. Now, the trick is to get rid of this log. Now, if we apply our little definition of logs, have a look at this. Over here, log x to base 2, the 2 pushes the y up. What we can do is we can say, this is a base. Okay, that is a base, and we're going to make it a base on the other side. So we drop the log, and it becomes a base on the other side. That 2 gets pushed up. So then x is equal to 25. Okay. Very important, you always remove the logs in a log equation. Okay, now the next one, let's look at another b. Okay, number b. What if you had log 4 to base x is equal to 2? Well, now there's your base, and we're going to move it to that side. So 4 equals x squared. This is the exponent here, it's lifted up. Now if you square root x, you get plus or minus 2. But now hang on. This is the base, and the base may not be negative. If you look at that there, the base may not be negative. In other words, a cannot be 0, and a cannot be 1, and a cannot be negative if you look at all of this. So if that guy, if that base there is negative, there's no solution to it. So what we do with this is we say, but x can't be negative 2. Okay, so therefore your x value would be 2. Okay, so be very careful with that. That's so important to remember that the base can only be between 0 and 1, bigger than 1, never 0, negative, and never 1, and negative, and never negative. And obviously the number after the log must always be positive. Okay, have a look at another one quickly, number c. Now it's starting to get very important. If you've got 2 log x is equal to log 25, what we've got to do here is we want to get rid of the logs. Now the first thing, I'm going to use law 3 and bring that little 2 up. So I'm going to get log x squared is equal to log 25. Okay, so that's your first step, bring it up. Now remember, if you've got log of this equals log of that, you probably agree that those are going to have to be identical to each other for these to be the same. So in a way, we kind of, like we would drop the bases with exponents, we kind of remove the logs. Okay, then x would be plus or minus 5 if you square it. But now notice, hang on. That guy, x can only be, the restriction says x must be bigger than 0, always. So you can't have x being negative 5. So we scrap that. Therefore, x is equal to 5 is the solution. So just be careful with that, because remember these if I go back and just revise it, it's so important when you look at the rules of logs. Okay, this guy must be positive. This a can only, the base can be either between 0 and 1, bigger than 1, but you can never have log of the base being negative 0 or 1. Okay, that's not allowed. Okay, so just be very careful with that. Okay, if we take another example, now it's starting to get very, very important. This is number D. Okay, D. If you've got 2 to the x is equal to 3, and you've got to round this off to 3 decimals, what we could do is say, well, okay, fine. there's two ways we could do it. We could sort of kind of latch a log onto both sides. We can log both sides. Okay, which is great because of course you can then bring that x down using the third law of logs. That's the one thing. Okay, then you simply divide both sides by log 2, and you would now have to use your calculator. And log 3 divided, if you use the log button in your calculator, you're going to see it'll come to about 1,585 rounded off to 3 decimal places if you so wish to use a calculator there. Okay, so just check there. Now notice this is by logging both sides you can bring down the x, but even better, your calculator has a button. You'll see it in your Casio calculators often have this kind of button like log, that, and what it's doing is that you're using the definition of log. So if you take, for example, 2 to the x is equal to 3, this is the same as 3 equals 2 to the x. Okay, now the base is 2, so it goes to the other side and it becomes a base at the bottom there, and x goes there. Now if you use your calculator, it's got that facility there, which you can then plug in the 3 and the 2, and your calculator then will work it out for you, and you can then get the decimal 1,585 rounded off to 3 decimal places. Okay, so that's an important thing. These applications of logs are going to be very important. And let me show you how interesting this actually is. If I said to you 2 to the x is equal to 8, you would probably agree that x is 3. Now, if you apply the definition of logs, watch here, and then you said log of 8 to base 2 is x, which the base goes down, and you did this in a calculator, you'll notice something that actually comes to 3, which is true. 2 cubed is 8. Okay, let's look at another one quickly, and then we can do a practice example as well. Okay, have a look at this one. This is number E here. If you've got 3 multiplied by 2x is equal to 0,3, and you've got to work out x. First things first, we're not going to multiply the 3 with the 2. We simply divide both sides by 3, and then 0,3 divided by 3, we can leave that there as, I'm going to actually keep it like that in as is, and then I could reverse this, so we could say 0,3 over 3 is 2 to the x. I've just repeated that here, but I'm not going to really work that out in the calculator at this stage, because I can do this directly. I can say log of 0,3 to base 3, divided by 3, and then you've got the base 2 there if you apply the logs. And if you work that out in a calculator to 3 decimal places, you get that. So there's a bit of an example for you to check out. Okay, do you want to try a practice example quickly? And let's see how it goes. But before I do that, just make very sure that you understand, if you've got log x squared cubed, okay, that is x is 2 cubed, that moves up and pushes there. But if you've got here x is equal to 3 to the y, that's the log of x to base 3, is why the 3 goes down and becomes a base. Okay, and remember with any of these expressions, when you've got log, you've got a base here and you've got a number here. Remember with this expression, this number here must be positive, only positive. It's never equal to 0. It's always got to be bigger than 0. Okay, and your base can be between 0 and 1. That's your base, or bigger than 1 if that's your B for base, but it can never, your base cannot be 0, your base cannot be 1, and your base may never equal a negative. So it's very critical to know that when you deal with that.